Assalamu alaikum dear students. Today our topic is reflection of light. So it's basically same as the reflection of any kind of wave. So by definition, bouncing back phenomena which occurs when light strikes the surface of another medium is called the reflection of light. Okay, so basically it's the same as we've studied in the case of any sound waves or any kind of electromagnetic wave. So first we have to study what exactly are the terms or the terminologies involved during the reflection of light, or during when we study the reflection of light we have to know about these points. So first is incident ray. Incident ray is the ray which strikes the other medium or the reflecting surface. In this case, you can see in the diagram, this is the incident ray. Okay, second one is reflected ray. Obviously, the ray after bouncing back from the reflected surface is called the refracted ray. Okay, so the first one was incident ray and the other was reflected ray. Okay, third one is point of incidence, the point at which the incident ray strikes the reflective surface. So where does the incident ray strikes the surface? Right at this point. This is the point of incidence where this ray meets the surface. Point number 4 is normal. Normal is the line drawn perpendicular to the surface. See, here is the normal drawn perpendicular to the reflecting surface. Okay, so why do we exactly draw these normals? What is the need of these imaginary lines? We just draw these lines to so that we have some, you can see it will be really easy to calculate these angles when we draw normal. Otherwise, what would do, we will have to calculate this angle first, and then we will have to determine this angle and this angle. So that's a lot of time consuming thing. So we will just draw a normal so that this angle and this angle would break into two equal parts and we can figure them out easily. Okay, that is purpose of drawing normal. Angle of incidence, theta I, we determine it by theta I, the angle between incident ray and the normal. Simply, this is theta I, the incident angle, the angle by which this incident ray strikes the reflecting surface. And similarly, angle of reflection, theta R, the angle between reflected ray and the normal, the angle between reflected ray and the normal. It determines by which angle the ray has been reflected by this reflecting surface. So this was basically what you needed to know about the reflection of light. Right now we'll study it in deeper content, but right now you have to just understand these 6 points, and you have to keep in mind the reflection of light is nothing else, it's nothing much more than reflection of any kind of electromagnetic wave or sound wave or any kind of wave, or you could say transverse wave or longitudinal wave. Is just the same as the reflection of any kind of vibration. Okay, so moving on to the next topic, which is laws of reflection. These are two laws of reflection of light. These are very easy. The incident ray, the reflected ray, and the normal to the surface all lie in the same plane. What does it mean? Coming back to our figure. The incident ray, the reflected ray, and the normal Here is the normal, here is the incident ray, here is the reflected ray. They all lie in the same plane. It means that they all share a common point between them, and that common point lies on the reflected surface. This is what the first law means. Second law is very simple and very important. The angle of reflection theta r equals to the angle of incidence theta I. Theta I equals to theta r. So here it is. When we draw normal to the surface, to the reflection surface, we will see that these two angles are completely equal to one another. Okay, so this is the case in reflection. This is the case which should be, it should be true for a ray to be reflected. These are two very easy laws of reflection. Very easy but very important as well. Third one is again image characteristics. Okay, so when this reflection of light occurs, what happens? Let's say this is a ray of light. It strikes the surface. What does it do? After reflecting, it carries information about this surface along with it. That's why we see things. Now, let's suppose this is our eye. Okay, it's not so beautiful, but let's suppose it's our eye. Why does it see things? Because let's suppose here is a book. Let's suppose it's a book. How does it see this book? Because when light falls on this book and gets reflected back to this eye, we see book this way. When this light wave gets reflected, it carries information about this book to our retina. Okay, that's how we see almost every object. Okay, so these image characteristics are important to understand the image formation, which is determined by the reflection of light. Okay, so images are formed in our retina when reflected rays of light falls on it. This is a very important point. You have to note it down. Magnification. The ratio of image size to the object size. Very simple. The ratio of image size to the object size. The bigger the image size, the smaller the object size. It means these are greater than 1 and the image would be larger or magnified. Because if the object size is small, image size is larger, then obviously that's common sense that the resultant image is larger. Because image size is the resultant image, object size is the actual size of the object. Second condition is image size divided by object size less than 1. It means if the resultant image shown in some kind of, you can say mirror, take an example of mirror. If the image size on the mirror is less, then the object size, the original size of the object, then this ratio would be less than 1 and the resultant image would be smaller than the actual object size. Third one is if the image size and the object size are of the same magnitude. It means if they are the same, then what would happen? Same would cancel each other and we will get a 1. So the resultant image would be equal to obviously the original size of the object. This was the first characteristics of image formation due to reflection of light. Second one is attitude. tells whether the image is upright or inverted. So what exactly is a upright image or an inverted image? Let's suppose this is a mirror. A man is standing here. Okay. So if in the mirror he sees himself like this, then the image is upright. But if in the mirror he sees himself like kind of this, then the image would be inverted. Third one is location. Location is the distance between image and optical device. This is a technical term. Okay, so how would we determine that? How would we come to know that image is formed somewhere else and the optical device is somewhere else? An optical device is kind of it could be a lens or a mirror, etc. Let's take an example of mirror. Okay, if mirror is here, but the image does not actually is formed exactly on the mirror. The image forms just about some distance away from the mirror. There are two conditions: if it's just away in the forward direction, or it's just behind the mirror. These are something else. Okay, you will study in the further topics, but there is a distance between the image formed and the actual placement of mirror, and this distance is called the location of the object. Okay, the location of this image of the object. Fourth one is type. It tells whether the image is real or virtual, that is, whether image is visible or not. So, have you seen an image which is invisible? Of course not, you wouldn't have. So, it tells you if the image would be seen on the mirror or not. Of course, there can be any invisible kind of thing here. The virtual means that there won't be any image even though a man is standing there. We will discuss why does it happen. A man is standing right in front of the mirror, but he won't be able to see himself. Why? There are some technical terms involved in it that we will study later. But right now we just have to know that there are real images or virtual images, two types of images. Real are the ones that you usually see in your daily life. A man is standing there and he will see his reflection in the mirror. Virtual image is that there won't be any image in the mirror even though the man is standing right in front of the mirror. So these three topics were included in our schedule for today. Thank you so much, everyone.